Okay, myself Ashok Kumar Kaudi. I'm in BE Mechanical Engineering and I'm Tech in machine design. So PhD in composite materials. So this video we are making only for the students like B students as well as for diploma students related to strength of materials. So useful for strength of materials. So before starting what is strength, we'll discuss exactly what exactly a load. Actually, load is defined as an external force acting on the machine part. So usually we have different types of load, like we have dead load, static load, we have variable load, and suddenly applied load, shock load, and impact load. So these loads will come into picture as well as in strength of materials and as well as in design of measurements, where the calculation as well as the construction of the buildings and as well as your columns, where you have to calculate the load. So after the load we have what is stress. Stress is very important part in design of measurements as well as in the strength of material. What is stress? Stress, when a body is acted upon by external force or load, a resting force is set up inside the body. Such a body is said to be in a state of stress, or the stress is the resistance offered by body against the deformation. That is called as stress. Let us look this diagram. There are no a single component is taken where exactly the load is applied in two different directions. They are exactly applied in opposite directions. If you see the figure, it usually shows that the load is applied and external force may be assumed to be uniformly distributed in the second diagram. If you see the diagram B, where exactly the first section is there and the load is uniformly distributed. This is an internal force offered per unit area of the body is known as stress. So usually if you define a definition, or you can say that the internal resistance offered per unit area is called as stress. That's the mathematically we can say stress as stress equal to force by area, or you can say F by A or F dash by A. Why you are taking F dash by A? You can see only in the first diagram you apply load in two opposite directions, F and A. This is what applied load. But if you cut the section, if you cut the other load is applied, naturally the internal resistance will get set up inside the body. That is exactly opposite to the applied force. That is F dash. You are taken as F dash. Usually when you come in equilibrium condition, so your F dash will be equal to F. F will be taken equal to F dash. Both are same. F is an applied load and F dash is the internal resistance set up in the body. That both are equal in the equilibrium condition. If you see the diagram, see where exactly the internal resistance is there, that is exactly opposite to the applied. You can see that is exactly opposite to the applied. That is what we can say as a stress, which is given by F dash by A, or it is F dash. Now, if you see the design of measurement concept, so usually we will take as rho as a stress, rho as a stress. So stress will be in the there in the body, that is called as rho is taken as a rho. In strength of material also we will design that contain rho as a stress, that rho equal to F dash by A and F is F by A. Where F dash is the internal resistance offered in the body and F is the applied load to the body, and A is taken as the unit area of the body or cross section area of the body. Right? So this is about the tensile stress in the body. So previously we discussed tensile stress. Actually it is tensile stress and compressive stress are the two types of stresses which will come under the normal stress. What exactly normal stress? Stress is different and normal stress is different. When I talk about normal stress, the internal forces and the corresponding stresses, they are acting exactly perpendicular to the surface. So perpendicular surface is known as normal stress. It is also direct stress. This is very important parameter in case of design of machinery. Right? So normal stresses are, as I told you, one is tensile stress, one is tensile stress, already we discussed. Right? So one more is compressive stress. Now we are going to discuss what is compressive stress. What is compressive stress? You can see the compressive stresses are the stresses which causes a load is acting in such a way that it pushes the particles of the material nearer, causing shortening of the material or shortening in the direction of the load. So naturally, if you push like this, so naturally the size of the component will get reduced. That is called shortening in the other term of strength of material. So thus that it means you are applying a compression load. Like this, you are applying a compression load to the material, both are in in the same direction. You can see not in the direction, in the same direction. That causes the material to shorten and reducing the cross section of the material. You can see this diagram, first diagram. Second diagram, you see the cut section. There are two again. If you cut it, the same section. So the resting force part is there. That is coming exactly opposite to the again applied. So applied only like this. But if you see the resting force that is developed inside the material will be exactly opposite to the applied. If you see this also, this is exactly opposite to the applied. Now if you combine these two things in a single component, so it will come like this. See again the compression load applied as well as the resting force set up inside the material will be exactly opposite to the applied load, or you can say the compression load, that is called as compression stress. Mathematically you see compression stress is the method given by again F dash by A and F by A, and F dash and F will be exactly equal to each other and within equilibrium state. Now if you take the parameter, you can say in mathematical term, that is resistive force, right? It will be F dash, same thing as written here, divided by cross section area of the material. That is called cross section area of material. Cross section area of material. That is called as the compression stress of the material. This is also an important parameter in case of design of machine and in case of standard materials. The last part of the term the stress is shear stress. Shear stress is very important in design of machine as well as in strength of materials. So usually the definition if you take shear stress, that is you can say as shear resistance divided by shear area. You can, that is also called as the dash area. If you take the shear resistance, that is called applied load F by A. Now shear stress will come into picture whenever there is nut and bolts. If you rotate nut and bolts and rivets, where you can find the shear stress. If you look into the picture, is a rectangular bound A, B, C, D, and there is usually the shear stress will be acting. Two equal opposite forces, they are acting tangentially across the section. You can see one force F is acting tangentially along the surface, and if you see at the bottom side there is an applied force F. These two are acting exactly opposite to each other. Then they will offer a shear stress, or you can say the compound is shear force, and the shear resistance will be at the bottom side F. Now the same diagram, if you cut into the two sections, you can see this diagram. There are cut sections like A, B and C. As the same thing, shear force is applied at the upper side. Shear force will be acting exactly on the top surface, that is called the tangential surface, and the resisting force will be developed right at the middle portion. You can say here the resisting force will be developed, and the body AB, C, the lower part will be equilibrium and F equal to F dash. The same thing if you say the upper part, if you cut section, and this will be C will be equilibrium when the resisting force as well as the tangential force are equal to each other, and the upper part will be in equilibrium. That's why mathematically you can say shear stress is the ratio of shear resistance divided by shear area, that is called as F dash by A. F dash by A is or it is F by A. So usually it is used in nut and bolts and rivets where the calculation of shear stress is taken. That's it. Thank you.